This video is intended to tell you about 7 wave behavior terms, and here they are. So let's get started. I'm going to try and go no more than 2 minutes per term. So I'm going to try and be done before 14 minutes. So emit, here we go. Emit, what does emit mean? My definition for emit is to give off waves. So anything that creates or makes and then gives off waves is an emitter of waves. A common example is the sun. You know that the sun gives off visible light, it gives off infrared, ultraviolet, it gives off lots of electromagnetic waves. So the sun is a wave emitter. Just because you can hear my voice right now, that means that a speaker is emitting waves. They're not electromagnetic. The sound waves aren't electromagnetic, but they're mechanical waves or compressional waves. As this thing pulses in and out, it makes these compressional waves. So a speaker is also a wave emitter. So I think that's good enough for emit. So next term, let's go to absorb. Absorb means probably just what you think it means, because you're probably thinking about like a sponge or a paper towel or something. Absorb means to take in. And since this is a video about waves, I'm going to throw that word on here. To take in waves. One example of absorption happening, let's say you've got a black t-shirt and you've got some bright sunlight shining on it. So that bright sunlight comes in and the t-shirt absorbs that sunlight and it actually turns it into heat. But since the sunlight came in as visible and it never left, it got absorbed. So absorption means to take in. An example of absorption with a mechanical wave. Maybe you've seen this stuff before. This stuff is designed to quiet rooms down. The idea is that sound waves, mechanical waves, come in and they bounce around in these little cavities and they quiet the room down. We'll talk more about another one of these words later that involves that. But absorb means to take in. Next word is transmit. My definition for transmit, it's kind of a combination of these other two words. If something transmits waves, what it does is it lets them enter and then leave. So I'm going to write it like this. To take in and then give off waves. So a good example is, say, a window. So you're standing on one side of the window and you're looking outside at maybe a tree or something. Let's draw a tree. That'd be fast and easy to draw. So we've got a tree out here. And so we're looking through this window. The light leaves the tree, it hits the window, and it has to go through the window to get to my eye. So the window is a transmitter. The waves came into the window, and then the window let them leave. So that's what transmission is, to bring in and then to give off waves. I probably could have said that a little bit better, but I'm going to keep going with it. How about this? A cell phone tower. A cell phone tower is a transmitter. Why? Because what happens is you make a call with your cell phone, the wave comes in, and the cell phone tower does a couple things to it, probably amplifies it or whatever, and then it sends your cell phone signal out. So we've got in and out happening. This is a transmitter. Okay, so 3 words down, 4 to go. Oh, one more example, I guess, before I move on. Right now in this room, you're listening to this video probably on a speaker, and so you're in the room. So what is the transmitter that's allowing the waves to get to your ear? Because the speaker is emitting the waves, your ear is absorbing the waves, and what's going on in between here? The air is transmitting the waves. Okay? So let's move on to reflect. Reflection you're very familiar with. We won't spend a lot of time on this one. My definition for reflection is when waves bounce off, how about a scientific word here? Stuff. So reflection is when waves bounce off stuff. So like a flashlight shining on a mirror or something. The light rays come in and then they bounce off. That's reflection. If you have a nice smooth surface, you can see an image. And if you have a rough surface, maybe the waves get scattered all over and you don't see an image, but that is reflection. Another example of reflection, maybe you've heard an echo before. An echo is an example of reflection. Another example of reflection that I found. Some people are out trying to catch some fish, so what they do with their boat is they emit some sound waves into the water, and then those sound waves come down to the school of fish and they reflect off of the fish and they bounce back to the boat, kind of like saying, hey, this is where we are. And that is that bouncing wave, we call that an echo. Next term up is refract. You will understand it. It will take us a little bit longer to cover, but it's a pretty interesting thing that waves do. Refraction is when waves turn, and I could write a longer definition, but I'm just going to put in parentheses right here. I'm going to write because of speed. So refraction happens when waves go into something or come out of something and their speed changes. And that speed changing causes the waves to turn. Let me show you an example. Somebody took a picture of, they aimed their camera through somebody's glasses. So what's going on here? Well, what's in the background is you see there's a city, and in the glasses you can also see a city. This one's blurry and this one's nice and focused. What happens is some people, they don't see so well, so we need to change the way that the light goes into their eye. We need to change that direction. We need to turn it. So we use the glasses to turn the light in such a way that allows them to see a nice image. And let me move on to a different example, or let me follow this up. So what we want is we want the eye to have this nice clear image form on the retina back here, but some people's eyes aren't set up that way. So what we do is we make a lens and we either shape it so it's bowed out or we shape it so it's bowed in. Those are called convex and concave, but putting these lenses in front of the eye changes the direction of the light because the light slows down inside the lens. And we'll cover that more soon enough. So next up is interfere. And when waves interfere, let's see, how about this? When waves affect each other. And in parentheses, I'm going to write plus or minus because there's a couple different kinds of interference. The example that I showed you earlier of this foamy stuff that deadens sound, that's an example of interference. Sound waves come in to the foam, they bounce around and they interfere with each other negatively and the wave gets smaller. Here's another example of interference. Let's say you threw a couple pebbles into a pond and looked at the ripples. And in some places, it looks like the ripples are gone. It looks like in this area right here, it looks like the water's pretty much smooth because the waves have all canceled each other out. That is interference. Another picture of some interference, how about this? Someone has thrown some pebbles into a pond, and you can see that in some places, it looks like the waves are kind of getting canceled out. Like right here it looks like there's nothing, and right here it looks like there's nothing, yet right next door there's kind of a big ripple right here. That would be positive interference, or we call that constructive interference. But my definition for waves, when waves affect each other, that will be probably good enough for this mastery quiz. I think for diffraction, I'm probably going to have to go to a new page, but let's see here. Diffraction. When waves diffract, what's going on? Here's my definition. Diffraction is waves spread out through openings. And so what do I mean by that? Here's an example. Let's say here's my classroom, and right here is the door. So outside my hallway, outside my classroom, there's this hallway, and if there's somebody out here talking, say they're talking here or here, and I'm standing right here in my classroom, I can't tell whether they're to the left or to the right. Why? Because when this person makes waves, the waves go down the hallway, and some of them come into my room, and they spread out through the door, and according to my ear, all I can tell is that it's coming from the door. The same thing is true if this person over here makes waves. Their waves travel down the hallway, and they keep going. Some of those waves come through my door, they spread out, and all I know is that the waves are coming from the doorway. That's what diffraction is. I found a pretty neat picture that'll explain it pretty well too. I guess it's a better picture than what I can draw. So there's this little lagoon, and imagine that you were standing, say, here, or here, or here. Out in the ocean, we've got these ocean waves coming in, but as soon as they hit this opening, they spread out. So this person right here would say, yep, the waves are coming from there. This person would say the waves are coming from there, and this person would say the waves are coming from there. So these big ocean waves, they all look like they've come from this one opening. That is diffraction. So I beat my goal of 14 minutes, and that is my video on 7 wave behavior terms.